Welcome to another section with Jory. In this section, you through Geospatial feature engineering with QGIS, and so I will demonstrate how to generate and create new features from Geospatial data that can improve your machine learning model. For this example, we'll be generating features for the prediction of flood extent in a given region in southern Malawi in Africa. So let's get started with QGIS. Here's our QGIS interface. There are 4 Geospatial data we'll be generating few features from. First one is Malawi waterway. So this is a waterway file in Malawi. So it signifies rivers, streams, and other canals in Malawi. Then the next data set we will be working with is Malawi wetland data. It signifies areas we have wetland in Malawi. The data we're working with is elevation, this elevation data in Malawi, elevation of Malawi, the raster file, and also the land cover Malawi. This land cover signifies different types of vegetations in Malawi. So over here, you can see that each pixel has different color. So each pixel signifies different vegetation type in Malawi. These are trend set of interest. As you can see here, this trend set consists of square polygon, and this polygon is about 0.01 degrees on each side. Now let's look at the features in our trend set. So we'll right click on our trend layer and open attribute table. From the table shown here, we can see that we have 4 columns. The X and the Y column here signifies the coordinates, and this coordinate represents the center of each polygon here in our train set, the center of our polygon train sets. Then our target variable here, we have a target column here. A target column here signifies the percentage of flood in 2015 in Malawi in a particular polygon. Then we have a unique ID representing each unique polygon. So the number of rows here signifies the polygon in our train set. So the first feature we'll be creating will be from our land cover. This is our land cover data. We'll be generating major land cover type in each polygon using this land cover raster data. So we'll be using a tool called zonal statistics. For us to get to zonal statistics tool, go to our processing toolbox, then we search for zonal statistics here. Then this is zonal statistics algorithm. So what we're doing, we'll fix these parameters. For the raster layer, make it zonal statistics. And for our vector layer, make it our train square. And the output column prefix, call it land cover. Statistics to be calculated, right click on this, then you unclick on all this and click on only major mode since we are looking for the major land cover in a particular region. Then we'll click on run to run our algorithm. So once this runs successfully, then let us go and check our train set and see the features in it. Open attribute table. Now, as you can see here, previously we had 4 columns, but now we have additional columns here. So it shows that after our algorithm, it appends a new column which signifies the major land cover in each region. This value is the pixel value. Let's move on to elevation data to get the minimum and the maximum elevation in a particular region. This is our elevation data. So we need the minimum and the maximum elevation data in each region. For that, we're going to use zonal statistics again. For our raster layer, we'll change it to elevation data. Vector layer still train square. We'll now change our prefix to elevation. Statistics to be calculated We'll click on everything, then click on mean, minimum, and maximum, since we this was is our area of interest. Then we click on run to run the algorithm. So this has been completed. Then we can go to our train data to check our attribute table again. And from here, we can see that 3 new columns have been appended. The first one, which signifies the mean, next one, the minimum and the maximum elevation data in each polygon. So the next feature we'll be generating is percentage of wetland in a particular polygon. So this is the wetland in a particular polygon. So we're going to get the percentage of wetland in a particular polygon using a tool called overlap analysis. So for us to get our overlap analysis, go to our processing toolbox search bar, search for overlap. This is overlap analysis. We click on it. So for the input layer, we're going to be using our trace square. Then the overlap layer, we're using our wetland. Click on OK here. Then run this algorithm. So once it's completed, you can see that unlike the previous algorithm, the output of this overlap analysis creates a new layer here called output layer. So let's right click and look at the features in it. So you can see in addition to our previously created feature, we have 2 new features called wet area and wet PC, which signifies wetland percentage. So the wet area shows the area of wetland in each polygon, while the percentage is the wetland percentage in each polygon. Just rename this value to rename, call it 3 new features. The last set of features we'll be generating will be from our Malawi waterway data. This is our Malawi waterway data. Is it over here? So what we'll be generating from this data set is the length of waterway in each polygon, and also we also get generating the count of waterway, that's the number of waterway inside a polygon. So what tool will we be using? We're using a tool called sum line length from our processing toolbox. So we search for sum and pops up on this sum line length. Click on it. And for our lines will be our waterway data. Then our polygon is going to be our train new features we got. Then the line length, that's the length of waterway. We save it as waterway line. Then the count, we'll save it as waterway count. When we're done with that, we then run our algorithm. The output of this algorithm, our sum line length, it creates a new layer. Let's look at the features at the table. So you see, in addition to our previously created feature, it has 2 new features called waterway line and waterway count. So you see some region, some polygon doesn't have waterway, some has more than 3, some have 4 to 5 waterway. So now let's rename this layer to train new feature 2. So the next thing we're going to be doing polygon. So from each polygon, let's get the nearest distance to the water line. So we'll be using, still through our processing toolbox, we'll be using a tool called distance sorry, distance to nearest hub, this to distance to nearest hub. Then the source point is going to be our newly created feature, that's train feature, train new feature 2. And our destination hub is going to be our waterway. Then the hub layer attribute, that is our destination point, layer attribute, will be using unique ID. So if you check through our waterway line, you check through the attributes here, you see that for each water line, we have a unique ID. So from there, then I want to make this our measuring unit to be in kilometer. So the distance I want it to be in kilometer. Then I run this algorithm, clicking here. So this has been loaded successfully. So the output here creates a new layer called hub distance. So let's look at table features from this output. So we can see, in addition to our previously created feature, we have 2 new features. The hub name, that's the ID to each unique water line. Then we also have the distance, that's for each polygon, the distance to the nearest water line, called hub distance here. We can now rename this our hub train distance to, let's call it final features, since this is going to be the last feature we'll be doing for this section. Now we have all our features generated. So these are the features we have generated. This column here: land cover feature, elevation features, wetland and waterline feature. So the next thing we're going to be doing is to export this our newly created feature as a CSV format, so we can use it in our machine learning model. So we're going to right click on this and click on export, save features as we right clicked on our final feature layer. So for our file format, we're going to be using comma separated value simplification in the CSV format. Then file name, go to our directory to save it, a particular file name. So let's call this file name Malawi GeoFeatures. Click on save. So you can also see the columns created over here. And we'll click, we'll uncheck on add save file to map. We don't want our save file to be added to a layer. Or we click on OK. This our file. We can now go to our file directory, clicking on that. Then we can see our newly created feature here called Malawi GeoFeed.csv. So you can also use this idea in creating several other features, the special feature of your choice. Thank you for your time. Stay safe and have a nice time.